Cool. So my name is Manasi. I am the CEO and founder of a company called Verta AI. We are based in Palo Alto, California, and we build infrastructure for data science and machine learning teams. So where do we start? A bit about me. That's a picture in case you can't see me. I am short, but my background is in computer science, so I slogged through a PhD writing papers about systems for data analytics, visualization, and ML. My thesis work ended up being on this system called Model DB that I'll talk more about. And I worked on applied ML problems at some of the usual suspects, working on the feed ranking at Twitter, ad targeting at Google, and so on. So the key part of my thesis work at MIT was a system called Model DB. And it's really funny that a lot of people here have asked me how it compares to a system called MLflow. And it turns out that MLflow is based on Model DB. So in case you're wondering, there you go. But this was a research project, and so the publicity was a little bit different from a product. So what are we doing at Verta? At Verta, we are building a model lifecycle management platform. And I'll talk about what that means. Essentially, as I was having a conversation earlier, think about SDLC, but for data science and machine learning, and we're building the infrastructure to enable that. The rest of the Verta team, Shantanu, who's outside doing demos in particular, we all come from a distributed systems background, so NVIDIA self-driving, document extraction, speech recognition, and so on. So we have been fortunate to have an interesting mix of data science and systems, and hopefully that will be reflected in some of the design decisions that we've made. So today I'm going to be talking about why data science and ML teams need to think about agility in a way that's very similar to how software engineering thinks about agility. And here's the reason why. So my first thesis is that AI and ML is changing, and this change has happened in the last, let's say, 2 years. Until then, a lot of the data science, AI, ML, whatever you like to call it, was very insight generating. So like, I build a few charts, here's a Tableau dashboard, here's a PowerPoint, and now you guys make sense of it or you implement it. However, we're seeing that this static, insight-driven data science is changing into production machine learning. That means that intelligence is being integrated into mobile apps, into web apps, into Salesforce, all sorts of applications that have data in it. So if you're driving a car and it's giving you a safety score, it's no longer good enough to get that score 3 days later. I want to get that score now so I can actually fix my behavior. So this transition is happening. And what that means for the life cycle is that the first life cycle was procure my data, build my model, and then make it a PowerPoint, or if lucky, put it behind an API. The new model life cycle is way more complicated, and this should remind you of the software development life cycle. You're procuring the data, building the model, you're rolling out the model, you're going to see how it's doing, find ways to improve it, and then build a better model. You keep deploying it, and you keep going. So in sum total, data science these days is way closer to software engineering than to research. So we're no longer building the best models possible. We want to build models that are good enough, integrate them into products, and then iterate with the product in mind. In particular, I want to draw your attention to Agile software engineering. So what we're getting to is how do we become agile when developing these AI products? Just a show of hands, who's familiar with Agile? Okay, everyone is. Awesome. Agile is a way to respond to change. We like it because it improves the delivery of new initiatives, delivery times, reduces risk, all the good stuff you want to do while you're building software. So why is it time to think about these principles for AI and ML? And we think there are 4 reasons. The first one, as I mentioned, is deploying models into products is more important than sophisticated models. The second one is constant model iteration. I don't know about you, but my accuracy on my offline data set looks way different from an actual user who's clicking on a tweet to like it or not. And usually it's a rude shock when those two things are very different. So the more that we can think about our models within products, we'll be able to improve them in a more meaningful fashion. Driving home that point, real-time performance, super key, data drift, super key. And the last one has to do with something we do in code a lot. We build code to be reused. We usually don't build code so that we throw it away in like 6 months. However, if I ask you to go back to a model that you built 6 months ago, I can bet that most people here, including me, would not be able to find it. Because, well, I'm not tracking it. It's in some folder in my old laptop. Good luck. So that's why we think that Agile, the time for Agile for AI and ML is now. And this is a broader trend. We're not the first people to talk about it. We do run a meetup in the Bay Area called the Agile AI and ML meetup. We have 50-odd people at our meetups, and we discuss best practices, trends. There's also great work coming out of Salesforce talking about how their Einstein team is adopting agility and automatically building models. And finally, Google, sort of the forerunners of a lot of the ML efforts, have been thinking about this for a while. So the key question is, all right, I'm running a data science team or I'm building models. How can I be agile in my day-to-day? And the answer is twofold. The first one is tools. Well, you need better tools so that you can build and iterate on things faster. And the second is teams. And this has to do with, is there a product manager on your team who's actually going to make sure that you're impacting some business revenue as opposed to just improving your model some 5% more? And there's more to speak about on teams that I'm happy to do offline. For the rest of the talk, I want to focus on tools. So this is an area that we focus on a lot at Verta, and I'm personally very passionate about it. So to understand what tools we need to become agile, I want to go back to what challenges we have seen in enterprise AI, and most people here can add to this list significantly. So the first one is ad hoc model development. I don't know if you can see that, but every few months there is a thread on Reddit or Twitter that says, how do you manage your machine learning models or experiments? Well, no one asks that for code because, well, you have Git, and that's how we manage our code. It's super hard to share data science knowledge. At Twitter, I remember spending about 2 months recreating results that an ex-employee had already created because there was no record of what hyperparameters had been searched, what results had been achieved, and what I should be doing next. And this happens all over. If you had an intern this summer and they have left, you have no idea what they did. And you're going to spend your time redoing all that great work. Next, I have a model. It's great. Oh, by the way, the production team can only deploy Python 2. They're not ready for Python 3. I don't know how many times that happens, but we hear that a lot, where the product stack can be quite different from the data science stack. And so it takes several months to take a model from research to a product setting. Finally, let me highlight the very strong need to have model monitoring. Who remembers Tay here? Chatbot from Microsoft. Super polite, super nice. Started off great, a few days on Twitter, and turned into a really abusive and racist chatbot. I really hope that our financial models, healthcare models, chatbots don't do that in practice. So we've got to hold ourselves to higher standards. So I'm talking about tools, right? And these are the 4 challenges. It turns out we solved these for code a while back. Right when CI/CD came into the picture, when Agile came into the picture. So these are versioning, we have Git. Collaboration, we have GitHub. Deployment, Jenkins, Circle, CI, whatever tool you use. Performance monitoring, we have this great stack called APM, New Relic, App Dynamics. So we've actually invested in building these tools for code, and yet at this point, we don't have them for ML. So my point here is tools are key. And at MIT, we started taking very baby steps towards this. ModelDB, it's open source, feel free to check it out, is a database for models. It provides a central repository for all of the work that different data science teams are doing, so that if someone else has built a model or generated a feature, I can reuse it instead of doing all of the work myself. And at Verta, our goal is to take it to the very end. I'm not going to go through the details of Verta. Please check out our demo outside. We're the first booth, and happy to have a more detailed conversation. I'm going to wrap up with a case study of how we helped a sales AI company become agile in their data science workflows. So here's a bit of background. This is one of the top sales automation companies in California. I would love to have the kind of revenue that they do, which tells me they're doing pretty well. They have 100+ employees, a 5-person data science team, very strong. Their charter is to build models that identify B2B leads. So do a lot of NLP processing, relational processing, identify B2B leads. And they're already using agile processes in terms of sprints, Jira. Every model improvement is tracked in Jira, the stuff that you would expect in software. The team structure is actually interesting. The data science team is separate from engineering, which I think is pretty typical. And while that's typical, it actually introduces a lot of inefficiencies in the process of taking a model into deployment, and I'll touch upon that in a bit. Finally, they have some data engineering support, but it's a rapidly growing team, so finding the right people and training them up can take a little while. Here are the key challenges they were facing when we went in. First one is slow model development and deployment. So you can train these models pretty fast. You get a GPU or get a beefy machine on AWS and you're good to go. For them, running this model on their huge data set used to be a multi-week task. So they couldn't do it more than, say, once a quarter because it used to take too long. They also had a hard dependency on the engineering team to deploy a model. As a result, they had to wait for 3 months for the eng team to catch up with Python and library versions for something that was just like, hey, I want to test this model on my millions of data sets, millions of documents that I have. The second issue was the lack of ability to innovate. So production systems usually have a set of environments that they can support, and data science doesn't always conform to them. And finally, the inability to track and share work. I've already described this before, but imagine having tens of thousands of models, and now you want to slice and dice them. You want to tag them. You want to categorize them by experiments, by who created them, when were they last updated, and so on. So what we did for them was we implemented the Verta Platform. It takes about a day to set up. This is SaaS, so a bit easier. If you version models in our recommended way, you can deploy things in a day. It's actually pretty simple. And then we did a long-term sort of longitudinal study. And the key parts I want to highlight that are distinct from our architecture, you can implement this in your own systems. We implemented a central model repository. So store all of your models in a central place, add metadata to it. Give the data science team self-serve for model deployment. They should not be waiting on engineering to test out their models at scale. Also, microservices and containerization is key. Please don't build monoliths here because you're going to want to move around different parts at different rates and using different components. The third one is auto-scaling workflows. As a data scientist, I really do not want to deal with AWS jobs, Celery, Fargate. I really don't want to. I want to write my Python, and someone else should take charge of scaling it up. So that was the third piece that we implemented. And the final one, as I mentioned before, we really believe that model monitoring is key to this. If you don't know what your models are doing, then it's likely it's going to come bite you later, and it's going to be rather unpleasant. What does this look like very briefly? We added a library into their Python ecosystem, integrates into Jupyter or Python scripts. It stores stuff into our platform. We deploy as endpoints. We monitor data going in and out. That's kind of the gist. So what did we see? Let's start with visibility. To begin with, they had very limited or no visibility into the host of models they were building. It turned out that they were building around 50K models. That's a lot. That's a lot for most teams. And imagine having to track all of those things, either in spreadsheets or not track them. Suddenly they were like, hey, these are the hyperparameter searches I have run. I need to explore this other space. That visibility was incredibly helpful for them. Second one that I mentioned before is model choice. They were first limited to scikit-learn, Python 2. Now they can deploy anything, Py3, Py2, PyTorch, BERT, TF, anything that is Python native right now. The time to develop and deploy a model went from 22 weeks to 3 weeks. And this is a combination of microservices and also versioning of models in a very particular way. So if you have all the code, you have the artifacts, creating a model deployment is not that challenging. Scaling it is, but one-off is pretty darn easy. I mentioned the last one, the second last one before. The final piece that really was the clincher for us is they could only do 2 model deployments a year, so fresh versions of their model with the ability to experiment at scale and also roll out models independent of engineering. They were able to ramp that up to 17 deployments in a year. So that's a very quick summary. I'd be happy to take questions about it. The key point I want to drive home is the right tools make all the difference. Your teams matter, of course they do, but you need to support them with the right tools. The 2 main ones I would highlight are model management, or a central repository, and rapid deployment. If you can actually ship models 8 times faster, this is clearly stretching it a bit, but 8x more product or business impact, however you want to count it. And this is for one project. I'm assuming people work on more than one project. And the thing to keep in mind for the long term is this is not going to be the only ML application you build. You're going to be building personalization. You might build fraud, or what other content should I show to a user. And more reuse means faster velocity. So in summary, here are the key takeaways. We are going from insight generating discipline of data science to data science and ML being a core part of the product. As a result, we will have to be agile. We got to move fast, otherwise someone else is going to do it faster than we are. What can you do next quarter, right? We're going into Q4. Everyone's thinking about what are the big milestones. If you do nothing else, implement a model management system. It's going to give, as managers, it's going to give you visibility. As data scientists, it's going to help you manage all the experiments you run. Empower your data scientists to iterate independent of the product. They should not have to wait on someone else to give them their blessing to test out a model. And finally, build in model monitoring before it comes and bites your product or your revenue in a nasty way. And to summarize, if you're looking for a partner in this transition, we are available. We have a booth. Shantanu at the back is our engineer. Would love to chat. I love chatting about anything from Kubernetes to deep learning to model versioning, whatever strikes your fancy. So please come find us. Thank you.
We have a couple of questions on Slack. From Edgar, concerning tools, do you recommend commercial products or open source to be agile?
I think it's a mix. It depends on how much bandwidth do you have. So like we created a build versus buy versus open source. With ML systems, the open source is actually it's not quite mature. So like for Postgres or MySQL, I would say, yeah, use that. Like why would you want to build or even buy? Just use the open source. Right now, we're still defining what some of these abstractions are. Also, if it's open source and there's one person on your team managing it and they leave, you're going to be in a lot of trouble. I would rather, even as a small company, we pay for some stuff. I would rather have someone else whose job it is to make sure that my stuff is running, and if something goes down, I can bug them at any time of the day and tell them, hey, I need to fix this. If you need a fork an open source product, it's usually hard to integrate your changes back upstream. And so you're going to end up maintaining a fork, which becomes very painful in perpetuity. So those are trade-offs to think about. There's a host of solutions. Happy to talk more after.
Josh asks, can we buy a model management system instead of implementing one? Absolutely.
Come talk to us. So ModelDB is open source, if you're into open source. We learned a lot between version 1, which was at MIT, and version 2, which is much more robust. We provide a managed service that runs on SaaS or on-prem. So check us out.
That's great. There's a couple more questions coming in, but we're out of time. So
you know where to find us. Thanks very much.